All right, and welcome to Flat Earth Civil Discourse, episode 15, with a concave earther, Zenith Atlas. Joshua, can you hear me okay, Joshua?
I can.
Okay, so please introduce yourself, and we'll get started.
Cool. I am Joshua James Bolliero, and I started this whole cosmological journey back in 2015 with Flat Earth, and I was involved with that for a little while. And it there, of course, right from the get go, there were some obvious things that didn't work with it, but I stuck it out, and there really isn't much evidence for it. So at this point, for me, it's either convex or concave, and so that's why we're here. I grew up in New Hampshire. Um, I've been several things. I've worked in restaurants. I've worked as a CNC machinist. I've worked in construction. Right now, I'm in Michigan and having lots of fun up here. Got some good footage. So, yeah, that's it in a nutshell.
That's great.
So
the conversation is usually between me and a flat earther, but I did speak. I think I told you I spoke at length with Lord Stephen Christ maybe 2 years ago on his channel. And he was really trying hard to convince me. And one of his big pieces of evidence was like mega cryo meteorites. And then he was like, think of the children, but so you used to be a flat earther, and then you decided that the evidence just wasn't there. So can you tell us a little bit about what is causing you to lean towards a concave Earth? Tell us about that. And actually another thing I wanted to ask you is, maybe this is another question, is what causes you not to feel that it's a heliocentric model?
Okay. Well, I guess I can answer all of that all at the same time. So I got into flat Earth. I basically saw a flat Earth clues video, and some of it stuck with me. And right off the bat, the first thing you're going to research, regardless of shape, is the motions, the axial rotation, the orbit around the sun, the distances involved with the heliocentric model, the outer space adjacent to a pressurized system that we have. And so when you go back in time and you look at how this was all formulated, you can see how it's at least possible that this is a deception. And then when you look at what NASA actually has to offer, with the first proof of the Earth being a convex ball in outer space being those moon landings, now you really got to start questioning, okay, well, right off the bat, their very first piece of proof was a lie. So now we got to, so once you cross that motion hurdle and you come to the conclusion that regardless of shape, more likely than not, we're living on a stationary surface, which makes a whole lot more sense if we're created beings, right? Why would a creator put us on a moving surface? It makes no sense. He'd just make the lights move, which is what flat earthers and concave earthers and some convex earthers, the geocentrists, they also claim it's the Earth stationary, it's the lights moving. Inside or outside of books, it's clear based on my own observation that we live on a stationary surface and the lights are moving, and they're a lot closer. So what got me into flat Earth was that flat Earth offers a lot of things that are true. This is a fact. Flat earthers also offer things that aren't true. So right off the bat, the three main things is obviously the maps, the stars, and the direction of weight, and what causes that direction of weight. Most people would call this gravity. Flat earthers and concave earthers agree that gravity is nothing more than a label used to describe an experience. It's a word that was used to explain why XYZ happens. And there's lots of us that don't agree that gravity is all that accurate. It's not that the science of objects moving down is false. It's how, you know what I mean? Like, things are still going to fall 9.8 meters per second, whether it's gravity or something else. So we're not challenging the 9.8 meters per second. What we're challenging is why, how. I don't think there's gravity within each object making two objects come together. I think it's rather the air, the ether, causing these etheric pressure, causing these two material bodies coming together. And there must be an up force and a down force. So that's something that flat Earth can offer. That and the maps and the stars. And number 4, the most important one, the measurable flatness doesn't exist. And of course, what comes along with that is the measurable convexity doesn't exist. It seems that only measurable concavity exists to be debunked to begin with. I can't find measurable flatness to debunk. I can find optical claims of flatness, but no one's measured flat. No one's measured convex. There's got to be a reason.
Well, when you say no one, frequently what people do is,
that
or
I know,
what
that I've
flat
seen, no one that I'm sorry, yeah.
well, they frequently flat earthers are citing other flat earthers, and they'll say, you know, no one has ever measured curvature. And now we have.
I'm sorry, say that again. There's a little bit of a glitch, so there's a little bit of a breakup. So.
Oh, sorry. People say no one has ever measured curvature, yet geodetic surveyors do it all the time. And so,
right.
you know, that frequently with
so
flat Earth now.
So how do flat earthers argue against that? Yeah.
Well, but they just deny the evidence exists. So, you know, we've got Jesse Kozlowski is in the chat, and you know this is his bread and butter, is making extremely long surveys over great distances. And he's measured curvature, you know, across a 1 mile pond, you know, where the water looked as flat as a mirror. And he found the curvature to be approximately 8 inches across that 1 mile of pond, you know, 1 mile of flat looking water.
Yeah. May I ask how is that? Because I'm interested, like, what did they use, like fishing line or lasers? What was the process?
Well, the surveyors use extremely precise angle measuring equipment called a theodolite, and so he shot a theodolite across this pond, and then he went to the other side of the pond and then shot back. So he had like either a measuring, you know, one of those surveyor rods
coming at each other.
Yes. So. And I apologize, Jesse, for, you know, I'm probably going to get this wrong, but this is how I remember his experiment. So on one side of the pond, he had like I'm going to say it's 30 inches tall. I'm just making up a number, but it was a surveying marker where he had like a target, but the target was 30 inches tall. Then on the other side of the pond, he had his theodolite exactly 30 inches above the water, and he shot back with a level, you know, like the theodolite has a level built in, and the 30-inch marker on the far side of the pond was approximately 8 inches lower than his level line, you know. So it was like an 8-inch drop in 1 mile that he measured with his theodolite. So, you know, it's a piece of evidence, and, you know, people, you know, can accept it or reject it, you know. But frequently flat earthers will say
a little bit. It's tough to hear you.
Oh, I'm sorry. Yeah, it might be bandwidth. So one of the things that you could do is maybe you could turn down your bandwidth. So
yeah, I'm in a hotel right now, so that might be the issue.
Oh, okay.
I'm using hotel Wi-Fi, so.
Okay. Yeah. So
I'm not hardlined in or anything. Yeah.
Maybe turn down your bandwidth. You know, like we don't need to see.
Can you hear me?
Yes, we can hear you fine, or I can hear you. I don't know if you can hear me. And so anyway, I'm interested in oops, hold on a second, add moderator. I'm interested in your take on NASA, because you seem to indicate like the moon landings, you know, was just sort of obvious that they were faking it. So what are your thoughts on that?
Well, there seems to be certain pieces of footage that are impossible if there wasn't a photographer there first already. Number one.
Any off the top of your head? Can you think of any?
Yeah, well, there's shots taken from the moon of the thing coming down. I mean, aside from that, I mean, how much have you? I mean, I'm sure you've looked into it a little bit, but it
I
seems pretty obvious to me that what we're presented is fake. Now, if what we're presented isn't what actually happened, I can accept that too. Maybe they did something that we don't know about, and they're just giving us all this fake. I'm just saying what they've told the American public clearly looks fake to me, to a lot of
yeah.
people.
Well,
I mean, it's not just me,
I,
you know, obviously. There's
I
there's lots of people that still think the heliocentric model is true and NASA lies, you know. So it's
right.
it's
I
not
get
looking good for those people. Yeah.
you. Now the thing is, and you used to be in the flat Earth circles a lot, and one of the things that they do is they like to make things look more fake than they actually are. Like they will literally take a shot taken on the ISS, and they will erase the background, and they'll paint it in green, and they'll say, look, they're using green screens, and then they'll replace the green with underwater, like the underwater lab, the neutral buoyancy lab, and then so like the end result is look how they're faking it, and it was
Right.
Photoshop done by a flat earther.
Right. Yeah, and I agree. And some of the best Photoshop comes from flat earthers. In fact, Mark Sargent uploaded a video that it's entitled SpaceX is real, don't research flat earth, and it's amazing. Yeah, I agree. In fact, I assert that NASA's fueling flat earth on purpose. I think NASA's given us footage so bogus. I think NASA and flat earth are all being run by the same hooligans.
Yeah,
So
well,
it makes sense to me that NASA would help flat earth. Flat earth will help NASA just keep people trapped in this endless false dichotomy.
yeah, that's
Is how I see it, now after
that's an
years and
interesting
years.
thought. But I just want to, and I don't want to spend the whole time with like Apollo, but I just want to say one
Sure.
little thing. Something you mentioned was that there was footage of the lunar lander coming down, and like there's no footage there outside of maybe a movie about Apollo, but there's no actual NASA footage of a lunar lander coming down. That is absolutely impossible. And so if you saw footage, you were either seeing something that somebody faked, or somebody pulled it out of a CGI of a documentary, and they're like, oh yeah, this is a documentary on Apollo, and this is how it you kind of.
So wait, you're saying NASA never claimed to put a what?
No,
I don't think I understand what you're saying.
There's no footage of a lunar lander coming down to the surface. There's footage of the I don't know what they call when the lunar lander breaks in half and the top half goes back up to rendezvous in lunar orbit with the command module. I forget what that's called.
Right.
So there's footage of the top half of the lunar lander popping off and coming up. That was done with a robotic camera. But there's no footage of the lunar lander descending.
Okay, so one thing I want to make real clear right now is that while I assert that NASA lies, because I'm not a flat earther anymore, and because I now have a new understanding of the sky, I now think it is possible that NASA is doing some things that flat earthers claim is impossible and just bullshit. I don't think NASA landed on the heliocentric moon. However, I do believe that NASA is on the other side of our real firmament at 100 kilometers. I think there's glass in the sky, and I don't think it's a flat Earth with a dome. I think that the Earth is a sphere like this. We live on the inside, and most of our universe is within that glass, and there's a barrier up there. And I think that NASA has gotten through. So if they've landed on a moon, they've landed on the concave Earth moon, not the heliocentric moon, 250,000 miles away in outer space. You see what I'm saying? So now I'm starting to think, wait a minute, maybe some of this footage that we thought was fake as flat earthers is now real, but it's not real in outer space. It's real in inner space.
Yeah.
So maybe space is real. It's just not on the outside of a ball. It's on the inside of a ball.
Yeah, it's
on the inside of the sphere, and the curve goes up.
It's an interesting.
And I've got some outstanding photographic, which is not measurable, but I've got some visual evidence that really is going to be a problem for both camps. I mean,
You mean flat and globe, right?
yes.
Okay.
Yeah.
So one thing really quick, and I'll be happy to screen share. Like, I don't know if you have your, this I don't know if you have visuals at the ready, but I'm happy to have you screen share. Okay. But one thing very, very quickly is that one of the problems, and I know you're not a flat earther, but one of the problems that globe earthers say to flat earthers is that the southern hemisphere just doesn't work. And so I'm going to segue into concave Earth in a moment. But the people in the northern hemisphere, we see the sun, quote unquote, circling around us. I mean, you can kind of imagine that the sun is circling the North Pole. But the people in the southern hemisphere, they see exactly what the people in the northern hemisphere see. So even though in the flat Earth model, and I know you're not a flat earther, I'm making an analogy. In the flat Earth model, the sun is circling the North Pole. People south of the equator, they don't see the sun circling the North Pole. They see the sun circling the South Pole. All right. So in other words, flat earthers have to convince people south of the equator that what they're really looking at is the outside of the circle of the orbit of the sun above the equator. So in other words, they're saying you're outside the circular orbit of the equator, but it looks like you're inside the circular orbit. So now I'm going to reflect it back to you with the concave Earth. We are in the globe Earth model, we're looking at a celestial sphere, say, and then the sun, moon, stars, are all moving within that virtual celestial sphere. But then the concave Earth says that, well, no, it's not the outside of a sphere. It's actually the inside of a sphere, but it has to work the same way. Do you see what I'm saying?
Well, because you're not trying to put everything on the flat plane, it's just a matter of inversion. So the celestial sphere, the virtual celestial sphere exists on both models, convex and concave. We still have a southern clockwise, and a southern clockwise and a northern anti-clockwise direction of all the lights in the sky. So everything works again because you're not flat. Once you go back to a spherical Earth, then all those flat problems go away. The maps, the stars, etc. So
I will give concave Earth that point, in that Australia could be exactly the same size, the same shape, the same surface area. You could have Antarctica, you can have a South Pole, you can have a North Pole. So the concave Earth has all of that going for it. Okay, yep. So I am going to give you that, because you can have the exact same area, surface area, of a concave Earth and a globe Earth, right? But the problem is that if you have an observer on Earth, whichever the Earth is, when they look up, they see the inside of the celestial sphere. In other words, it looks like we're inside of a dome, whereas if the Earth were concave, you'd have to do some kind of, people call it bendy light, some kind of bendy light, such that it would be stimulating being on the inside of a sphere, even though you're looking at the outside of a celestial sphere. Does that make sense?
Right. It does make sense. It's in it and like a flat earther, I'm going to say that it literally is because of perspective. And what I mean by that is any eye, whether it's flesh or machine, it can only see so far. So everything has a limited viewability range. Your own Truman Show bubble range dome that even Jaron talks about. You know what I mean? This is just common sense. Any eye is only going to be able to see so far in any direction. So because light's coming through this barrier in the sky, okay, that's the reason why rainbows bend down, is because everything's being inverted. We're looking up at a convex. We live on a concave surface, so that means that we're looking at a convex one. That light's coming through a concave surface and coming out like this. And so it really is that simple, and that's why, like in one of my recent videos, I show the moon, and the Terminator line just doesn't make sense. Light would have to bend. Also, when we see the bottom of the moon, we're actually seeing the top of the actual moon. See, the lights that we see in the sky aren't actually there. They're actually literal apparitions. They're just the actual sun and moon are on the other side of this glass firmament, if you will, this negative refractive birefringent glass and ice, barrier. So that's why we have all these discrepancies on the position and the altitude of the sun. That's why no one's ever going to figure it out, is because everybody's seeing their own sun. Namely, if we've got flat earthers claiming the sun is right there in the clouds, and I've captured footage like that. We all have. You slap a filter on it, and it changes it looks a little different, or whatever. But then you've got a high altitude balloon at 20 miles, and the sun looks like it's right there. And this is all happening over Boston. And then yet, over there in LA, they're filming the sun in the clouds. And up in the balloon, they got the sun at 20. So now we've got 4 different suns, and this is happening everywhere all over the earth. And I assert that if we live on the inside of a curved surface and the light source is coming from the center, that's why everybody's getting the sun in their own sky. That's why everybody has a different quote unquote position of the sun. Everybody sees it in their own sky in North America, right in the clouds. It's impossible on a flat earth where the sun is like an omnidirectional light ball just moving underneath the firmament. So how would we even see in color to begin with?
Right.
I
agree. It doesn't work on the flat Earth, but it seems that you're asserting that it doesn't work in the globe Earth either. The thing about this balloon footage is that they're not bringing theodolites up on their balloon. Like, so whatever you're seeing it's usually a GoPro or a GoPro type camera. And there's no measurements of angle of, everything is distorted because it's usually a fisheye lens because, if you're going to send up a balloon, why not put a fisheye lens? It looks cool. So there's no measurements taking place, so I disagree that it sort of is kind of eliminating the globe Earth model, all this balloon footage. I think it confirms, it confirms what we see here on the ground just fine.
Well,
oh, you just cut out. I can't hear you. You're on mute.
Okay, I'm sorry. I said now might be a good time to screen share. May I do that?
Yes, please do.
Okay, cool.
I'm going to put myself on mute because my kids are running around upstairs. I was going to put them to bed.
Okay.
So I'm putting myself on mute.
Sure. So right here, so we'll just go to some, oh look, plumb bobs. There's another way to find curvature. So I'll just mute this here. Okay, so this, I got the whole flat earth community on the same page with me that this is obviously a small, close light source that's close in proximity. And this is going to be very slow, of course. I knew that was going to happen. It's not going to want to play a lot of this. Here we go. So let me see if I can find a great example. There's many examples where you can clearly see like a really close hotspot right here. And I'm actually going to show something. This is actually at my Facebook page. This is something I found that was right in the glare, right at the right moment. You can catch this strange diamond-shaped object in the sky that we're going to see in just a second. So this looks to me like a very close light source right here. I don't assert how anyone can possibly, especially where you can see where the sun's range is starting to diminish. There's more Earth over here that can't be seen because the light doesn't reach far enough. This is obviously I assert this is an apparition, and this is evidence of the barrier. This is a diamond-shaped light source that can only be seen through this little flare, whatever. And this obviously looks very close to me. There's a multitude of high altitude balloon footage that I mean, while no measurements are being taken place, and I agree that optical evidence should not be. I mean, tangible measurements is obviously better than optical stuff. However, I mean, to me, this is obviously a small close light source. Now, what the heck is this? What the heck is this diamond shape up here?
Yeah.
Um,
So
we could speculate all day long about that. I'm not going to go there.
yeah, well,
But the point is that we're obviously, call it a belief. I admit it, but I mean, I believe this light source is very close. I'm going to say that, and I don't believe it's the actual sun. I believe it's an apparition coming from the other side of this barrier that I assert is at 100 kilometers, because there seems to be lots of supporting evidence of lots of things happening at that very specific altitude.
yeah, I get that footage looks, it looks like the sun is very close. Like if you look down, that you could see the glare or the reflection of the sun, between the clouds. It looks like maybe there's a body of water. But then the question is, the people who are down there, like, that body of water has a name. It's a lake or an ocean or something. Well, there are people who live there.
Mhm.
What are they seeing when they look up? Because what I would argue,
Exactly. I don't think they're seeing the sun this high. I think they're seeing the sun closer. They are going to see the sun down here. See, I think the sun always appears close to you because it's only an apparition on this side of the glass. I think there's a physical sun and moon moving inside the spherical firmament, and we live outside the spherical firmament. Now these people that lived up, they're not going to see the sun here. The camera is only seeing the sun here because this is where the camera is. If the camera was down there with those people, then the camera would see the sun where those people see it, probably right above the clouds or in the clouds or whatever. The people way over here to the left of the screen, they're not seeing the sun way over here. They're seeing the sun right above them too.
yeah, see, what I would argue, and the thing is,
And
this is
so
all,
that has nothing to do with the shape of the Earth. I just want people to understand that this, regardless of shape, flat, concave, convex, regardless of that, I assert that the sun we see is not the actual sun, but the sun we see is based on the actual position of the sun. You see what I'm saying? It's but what we see on this side of the glass, because we can't really see the firmament or see through it. And there's supporting evidence I'll show where even humans can reproduce that. We can mask objects with bending light, just magnifying glasses lined up. So it's very easy. If we can do it, a creator can do it. It makes perfect sense to me once you spend enough time pondering it.
right. Well, but the key question that I would have is, do you see any distortions in the sky? So one of the things, like if you take a bunch of magnifying glasses and you line them up, then you're going to see distortions. I mean, like maybe it looks great in the center of the frame, but as you move to the edge of the frame, things start to warp and distort. And one of the things that, like, if you go to a place with a great night sky seeing conditions, like the middle of a huge state park, far away from the nearest city, then you look up, or you do sky watching in the desert, you see thousands of stars, but you don't see any distortion. You don't see any distortion. And if you map the constellations of all the stars you could see literally 50% of the celestial sphere. Not 45%, not 55%. You see exactly 50%, which is exactly what you would see if it were a globe with really far
But it's
stars.
exactly what you would see in the concave Earth model as well, because light's bending up and ultimately returning back into the other side of the celestial sphere where the Gegenschein is, which explains the lunar eclipse. We only see half of the celestial sphere as well. It's all.
Yeah.
It's all.
Well, okay. So can I just screen share? I've got a graphic that I made in Keynote. So I don't know if this is going to work. So you'll have to just give me a verbal. Let me see. I want to turn on screen sharing. I'm going to say application window, concave Earth diagrams. Okay. So I don't know if you can see this. This is a basically an image in Keynote.
Okay.
So what you see is sort of an upside down clock. I mean, you see a right side up clock on the bottom. So what we have here at the very, very bottom, and is, let me see if I can I'm just going to draw an arrow just so I can kind of point to things. So I'm just going to make an arrow real quick. And I'm going to make it what color? I'll make it pink. Okay, so our observer is here at the bottom. So where that black dot is, or where the pink arrow is indicating, our observer is down here at the bottom. So if he looks up in the sky, he sees 180 degrees of sky. Like, let's say he's looking from due east to due west. So let's say over here he's looking due east. So where it says 3, he's looking due east. Where it says 12, he's looking 90 degrees straight overhead. And where it says 9, he's looking due west. Does this diagram make sense a little bit?
I sort of. I don't know that those lines, like, I don't know that light is bending the way you have these red, blue, green lines drawn. But we'll go with it. That's cool.
Okay.
Yeah.
So
I get what you're saying. Yeah, light's bending up and going. So we only have right.
So the observer perceives a virtual dome above his head. I mean, it's not an actual dome, but I mean, he sees, he could point and he can count the degrees. He could say, I'm pointing due east, and then
from 90
degrees overhead, and then 90 degrees, I'm due west. So he sees 180 degrees from due east to overhead to due west. Now, above us is the celestial sphere. And the thing is, and so what I did is I just mapped out, I just, copied the clock. And so for the celestial sphere to appear completely undistorted, like the constellations don't ever warp. Orion doesn't stretch, right? He never stretches.
You're talking about parallax, right?
No, I'm not talking about parallax. I'm talking about, like, everybody knows what the constellation Orion looks like because they see it in both hemispheres, because it's right on the celestial equator. Well, you could draw a map of Orion from Australia, and you could draw a map of Orion from Michigan, and it's the exact same picture. Maybe the people in Australia, they see Orion upside down from the way we see him. But it's the positions of the stars and the angles between the stars is exactly the same. It's completely undistorted, right? And it also looks that way when it's on the horizon. Like when Orion is rising in the east, or when Orion is setting in the west, Orion is exactly the same shape. So what I would argue is that if Orion is over here at the 3 o'clock position, right over here, like this is the actual constellation Orion over here at 3 o'clock, well, the observer is going to see him on the horizon, right? Now Orion is going to move over here. Now Orion's at the 2 o'clock position. Well, the observer is going to see him rising in the east. So the observer is perceiving rising in the east, and eventually it's going to be overhead and then setting in the west. But in actuality, if the Earth were concave, Orion would have to be moving along the outside of the celestial sphere, right? So that's why I have these lines drawn the way they are, and they're all equally spaced. They have to be equally spaced because we see no distortion. We don't even see a degree of distortion. Does that make a little bit of sense?
Well, I disagree that we don't see distortion. I mean, when you look at the time lapse, I mean, if you're like near the poles, then and you're looking at a pole, then yeah, it's going to be pretty circular. But there's places in like near the equator where they're kind of seeing like it's swirling, and I do see distortion in time lapse footage.
Okay,
so well, I don't know how to answer that question because I do see yeah.
Well, the distortion that I think you're talking about is when you film a time lapse with a wide angle lens, like a fisheye, like a GoPro,
Right.
So the GoPro has got distortions built into it. But what if you are not looking at a time lapse? What if you are like just taking a standard camera? And I don't know if you're familiar with the millimeter lengths of camera lenses, but it used to be they would say 50 millimeter lens. This is when we used to use 35 millimeter film. So a 50 millimeter lens was called a standard lens. So you'd literally hold the camera up to your eye, and then you'd pull the camera down, and literally what you saw through the viewfinder is exactly what you saw with your actual eyes. Like you weren't zoomed in, you weren't super wide angle. All right. So if you use a camera that either uses a standard lens or even zooming in, so that you can see, say, the constellation of Orion takes up the full frame. Okay. You
Sure.
could photograph Orion on the horizon. You could photograph him overhead. You could photograph him setting. You could photograph him in the Arctic, from the equator in Australia. And every single photograph will be exactly the same. The only difference is Orion may be turned at a different angle. Maybe he's upside down. But the orientation of the stars and the angles and the distances between those stars won't change. In other words, there will be no distortion whatsoever in the
Right.
constellation.
Why would there? Yeah. Why would there be in the concave model though? If it's just a direct if it's just the same virtual celestial sphere inside versus outside, why would we expect there to be anyway?
Okay, so I'm gonna. Oops, I just lost my picture. All right, I'm gonna screen share again. Oops, can I screen share application window and concave Earth diagrams? Okay, so are you back? Are you back on my my keynote slide?
I see it. Yep. Yeah, you're sharing. You're sharing. You're good.
So the reason why I say it doesn't work in the concave model is that these lines are there's crazy distortion with the lines. In other words, the observer who's down here, he sees no distortion, which means, it could be the inside of a dome, right? He could paint the constellations on the inside of a dome, right? But if what's actually happening is that the constellations are on the outside of a sphere, you have to have these crazy bending lines because they're equally spaced. Like, that's the thing I was trying to do with the red, the green, the blue. I was trying to have them perfectly equally spaced. Like the line that goes through the 11 o'clock position, it has to hit the 11. Same thing with the 10, same thing with the 1 and the 2. So for us to simulate what we see looking like a dome, we have to have these crazy lines of distortion. And the next thing I have to say is that we see exactly 50%. So let me point with my pink arrow. Hopefully you can see my pink arrow. So my pink arrow is just past the 3 on the celestial sphere. We can't see that star. We can see the star that's at the 3 perfectly on the horizon, but we can't see a star that's just 1 degree away. And that literally doesn't make any sense. Do you see what I'm saying? If we could see exactly 50% of the celestial sphere, these lines of distortion are pretty crazy. And that's the argument against the concave Earth, is that what we see in the sky is an actual celestial sphere.
Okay, so what you're saying is we're on the outside of the ball, and there's a celestial sphere around, like, bigger than the Earth sphere, and that we're seeing that virtual one or whatever.
Many light years bigger. Yeah.
Many light years bigger. Okay, so if I can reciprocate with a screen share of my own, I can show you how it's explained in the concave model that makes sense to me.
Sure, go ahead.
Okay, so for all you flat earthers out there, get ready. Try and just chill out. Please. All right. I just got to find it. This is a very extensive playlist, so sometimes it's tough for me to find things. Here we go. Okay. So in this model here, the observer still has this virtual dome. And I mean, I'll just let it play. I really don't need to say much. In this manner here, you see exactly half of a rotating celestial sphere. Now, in this model, it's the sky moving, not the Earth. And because light bends up, we only see half of the celestial sphere that's on the inside.
Okay.
Of course, what you don't see here is layers of glass, you see? So based on your position, the stars are just going to move about your virtual dome in the same manner that then the stars, they're not changing on the celestial sphere, so they're not going to change on your virtual sky dome Truman show either. It's just a direct inversion. So you're seeing it rotate like this. And, flat earthers, that's why this is called flat earthers' worst nightmares, because this is one of the obvious things that destroys flat earth, and rightfully so. So whether we're seeing the inside or the outside, the same observations are going to be possible, in my opinion. I don't see how it wouldn't work. Now, mind you, this model here doesn't show you the concentric layers of glass in between the celestial sphere and this one. This diagram here doesn't show you that there's a barrier above you at 100 kilometers, and then other barriers inside. So he's omitting those layers of glass, if quote unquote glass, for the sake of understanding, what's happening. And it's those very layers of glass that are helping all this light bend. I don't think light would bend like that without all those layers of glass and, water or whatever like that. But it's not shown here in this model, but in this particular, but this is basically what's going on, and it makes perfect sense as far as I'm concerned.
Doesn't it bother you that there's such extreme distortion, such that it looks like we're on the inside of a sphere, right? So in other words, we have it's like holding a basketball in your hand, right? Holding a basketball in your hand, but actually having it look like you're inside an inside-out basketball. It's like that would take an incredible amount of precision. It's like a precision of distortion such that you don't see any distortion. Like, doesn't that bother you?
Well, I mean, if we're looking at, if we're on the inside of a ball looking at a smaller ball, we'd still only see half that ball. So, I mean, even without bending light and all that stuff, if we're, if we're inside a massive ball looking at a celestial sphere that is a rotating ball itself, well, we should only see half that ball. Whether we're on the inside or the outside is almost irrelevant.
So if we have a globe Earth with a nearly infinitely large celestial sphere, right? We will see exactly 50% of that, right? So that's the heliocentric model. We see exactly 50% of the celestial sphere.
Right, that would work in that model, yeah.
What the concave Earth is proposing is that the celestial sphere is, and I'm just going to call it a basketball. It's not, it's not obviously not actually a basketball.
Sure,
right?
It's a star ball or whatever, yeah.
It's a star ball, but like what we're seeing is like when we look at our horizon, we're actually looking at the equator of the basketball. So we're looking, literally, we are looking due east, and our line of sight has to curve 180 degrees such that our line of sight hits the equator of the basketball. Does that make sense?
No, I'm not really. No, I don't follow you.
All right, let me.
Well, if you look, if you're looking at the equator, quote unquote, of the celestial sphere, then that would, the only way to do that would be to be looking directly above you from the equator of the Earth equator. You know what I mean?
All right. I'm sorry. Say that whole thing again.
Yeah, you were cutting out too, so I couldn't really understand what was happening.
Okay. Just repeat what you just said.
I'm trying to remember what I just said. Okay, well, what I just said was in regards to what you said.
You were talking about stars on the celestial equator.
Oh, okay, right. So in the heliocentric model, you've just got the Earth equator and then outer space. And so if you were to call outer space the celestial sphere, it really doesn't have an equator because we're spinning, we're orbiting, and all this other stuff. So outer space has no equator.
Well,
so there's that. So in the concave model, the Earth has an equator and the celestial sphere has an equator. Okay. That's something unique to the concave model, is that the
Okay.
celestial sphere has its own equator. Yeah.
The thing about the celestial equator only exists because the Earth is turning on its axis.
In the helio model, right?
Yes. So it is true that outer space, there's no equator in outer space. But if
Right.
you're an observer on Earth, you see the celestial equator based on the motion of
Correct.
Okay.
Correct. Yes,
So
and that's actually what's being shown here with this blue line, is that celestial equator.
right. Right.
Okay.
But the thing that is really kind of like mind-numbing to me is that you have perfect distortion producing no distortion. Do you see what I'm saying? Like if you were to literally hold a basketball in your hand and have that basketball appear as though you were inside of it and
Right.
looking at
I understand what you're. Yeah, I understand what you're saying. Right. So what you're saying is you're trying to tell me that this star ball is rotating inside the Earth, coming through layers of glass and water, and we're seeing no distortion. Right. I get you. And so
right, like
that
not
has
even
that has to be something only a very precise creator could do. And who else could also make the eyeball?
yeah, okay, well
That
that's another
also would take a very precise creator.
sure.
And every creature has a different eyeball. So if we're talking about an all-wise creator that created all of us, then we have to accept that there's going to be a creator that can perform these optical tricks, you know.
Okay.
And so I understand the question, and it's a totally legal and fair question.
Sure.
Yeah.
Well, the thing about the creator is like he should be omnipotent, you know? And so he should be able to create the heliocentric model just as easily as he creates the concave Earth model.
Or
But
the
if he
flat,
creates
right?
the concave Earth model, he has to also build in all this perfect distortion that shows no distortion, such that it looks like we're in a heliocentric model. Does that, like, for example, our
That would be a
observation?
pretty good deception, huh?
Well, like I don't believe that God is Loki, you know. So
Right. Yeah, I mean, we can leave, like, we can leave religion. We can make this about science, you know what I
sure.
mean? But
Okay. So can you focus? So we have, let's go just 15 more minutes. Okay. And then like, if we have lots of undiscussed
sure.
topics, let's have another hangout. But let's go about 15 more minutes. So let's aim to stop at 11. Okay. Can you talk
Sure.
about the very
All
specific
right, cool.
things, heliocentric model that bother you?
I'm sorry?
The things in the heliocentric model that tell you that we don't live on a globe.
Well, I'll actually stop Green Sharon. And if we only have 15 minutes, then I'd like to answer this one, and then I'd like to just show some evidences of my own before we.
Sure, absolutely.
Sure. Well, the main thing for me about the heliocentric model is, okay, if you have the sun and you have the Earth, okay, and nighttime is always going to be facing away from the sun. So nighttime for people on Earth, I don't have a. Here we go. I'll just grab this thing. All right. So let's say we have an Earth and we have a sun. Okay. And the Earth is orbiting around that sun once a year. Okay. So if nighttime is always facing away from the sun this way, so that means, let's say it's January, right? And it's nighttime, and I'm looking that way at outer space at nighttime. Then that means that 6 months later, okay, 6 months later, I'm going to be looking at an opposite end of the universe, looking at nighttime, but I'm still seeing the same stars.
So at high noon, right? It's nighttime at high noon.
Nighttime 6 months later should be looking at the two opposite ends of the universe. So how do we see the same stars all year round if 6 months later I'm looking at an opposite direction of outer space?
So the question is, are you seeing the same stars, the same constellations on the equator? So, for example,
what I'm saying is that, all right, so I worked third shift for a year. So I actually, as a flat earther, right when I was starting this, I actually became a flat earther working third shift. And so every night I'd go out and I'd see the same stars in the same spot at break time, with relatively minor change. Of course you have like daylight savings times and whatnot, so that would change a little bit. But for the whole year, I can see the Big Dipper all year round.
yes, it's called
when there's not so many clouds and stuff. We see the same stars all year, every year, for thousands of years. So right there, the heliocentric model has problems because it's claiming the sun's moving away from a big bang and the sterile parallax isn't there. For thousands of years, we still have the same constellations. And even if the sun wasn't moving, even if the sun was stationary and the Earth is orbiting around the sun, it still doesn't make sense that 6 months from now, I'm going to be looking over here at outer space and I'm still seeing Orion, Big Dipper, all that stuff. That's a huge problem. So I assert that the Earth is stationary, the lights are rotating, orbiting, regardless of shape.
Okay, so can I address that? About the signs of the zodiac. So, for example, I'm a Taurus, and I don't know what you are, and Capricorn. Well, it turns out that in the sky, in the celestial sphere, there's the 12 constellations of the zodiac, and they are actually named for where the sun is during that quote unquote astrological sign. So, for example, I was born in May, and I forget when exactly Taurus is. But like either April, May, or May, June, I forget which one it is. But basically on my birthday, and when I look up in the sky during the day and I see the sun, if you were to eliminate the blue sky, the sun is actually in the constellation of Taurus. Now I can't see it because it's daytime. So if it's nighttime, I will never, ever, ever see the constellation Taurus on my birthday because the sun's in front of it. Does that make sense?
It does make sense.
I'll see a bunch of other constellations. So, for example, in
predictability and celestial mechanics, I think it makes more sense in the concave than on the outer helio.
Well, the thing is, the concave model, if you allow for a sphere to look like a dome, the concave model works just fine. Like I would say that's a bit of a stretch to have a sphere look like a dome, right? So the constellations are on the same.
I do agree.
Yeah. So the constellations are in the same place in the concave model. They're just on the outside of a virtual celestial sphere. All right. But the thing that you're saying is a problem with the heliocentric model would also be a problem with the concave model. Because you wouldn't be able to see the same stars, or at least the sun would be in front of the same constellations throughout the signs of the zodiac. I don't know if I'm making any sense. So, for example, in May, you can't see Taurus. In I don't know, is Capricorn, is that a December?
That would all work
January. I'm sorry. Go ahead.
Yeah, you were just lagging out there pretty good, so I didn't hear what you asked. You said something about Capricorn in December, or I can.
Yes.
Can you hear me?
You would not see. Yes, I can hear you.
Hello.
I think there might be a lag.
Okay. Yeah, there is definitely.
Okay. Yeah, I think it might be the hotel Wi-Fi.
It might be. I was all right earlier on Hangouts, but
yeah. All right. So go ahead. I kind of interrupted you there.
No, not really, because I just muted my mic because I couldn't really tell what you were saying, so I just waited till sound is done. So as far as first of all, the celestial sphere rotates at a different speed than the sun and the moon move. The sun is quickest, obviously, with 24 hours. And then, the celestial sphere rotates at a different speed, which is 23 hours, 56 minutes, and about 4 seconds or so. So there's going to be a difference with the two. And so that's how you have celestial predictability. celestial
So
mechanics.
you're talking about the
And
concave
we
model.
still have planets orbiting around the celestial sphere. So it's not like, as a flat earth, you have to, whatever. There really is a solid common ground.
All right. So here's a question about, and that's about satellites. You say that you believe that NASA, if they did go to the moon, they went to the concave Earth moon, but like, what's your take about orbits?
You're lagging there. I didn't hear your question.
Okay. What is your take on orbits?
Orbits of what?
Of either satellites or rockets or, space missions? Like, do you believe that things can orbit? Like, for example,
Oh, of course. Yeah, I think I mean, it's a flat Earth claim that satellites don't exist. Satellites exist. That's a reality. They're just on the inside, not the outside. But there is space. There is a place. There's places NASA can travel to, and I think they have gotten through the glass.
Okay. So the point that I wanted to make about orbits is that in the heliocentric model, an orbit is where you match the centrifugal force or centripetal acceleration, however you want to talk about it, with the force of gravity. So you move in a circle fast enough, then you can remain in orbit. Whereas in the concave model, your centrifugal force would be in the same direction as gravity.
Well, in the concave Earth model, gravity isn't all one direction, which is the huge problem for gravity, is that it's a singular pulling force. In the concave Earth model, you have a push and a pull. So now that's how equilibrium exists, is because I don't think gravity is, I think Tesla was more accurate when he talked about universal compression, where I think there's a push and a pull. And so now if there's a sink force and a lift force, now that changes everything, because now NASA can keep stuff up in the sky, which flat earthers aren't going to like, but too bad.
Well, do you understand that I was going to say that in the concave Earth model, gravity or whatever you want to call it, it is pointing towards the ground, right? So if you have
here, but not necessarily at that altitude. There may be an altitude where quote unquote gravity goes the other way.
Okay. So
see
that
what
would
I'm saying?
Right. But that would
Which is exactly what NASA claims, because NASA claims that there's gravity on the moon. NASA claims that every object has its own gravity. You see what I'm saying?
Well, it's based on mass, yes.
Right.
But what you're proposing is that low to the ground, gravity goes towards the ground, but then, like, let's say even on an airplane, like you can walk on an airplane, so you could feel gravity on an airplane, but yet if you go up higher, somehow gravity turns upside down. Like that, that sounds
here's the thing. We're assuming that NASA is up there in quote unquote space. Now, if space is water, well, then that explains why where flat earthers have to claim it's neutral buoyancy lab stuff when it's not. It's because maybe what's on the real firmament, maybe NASA is in water up in space. That's what I'm getting at.
Yeah. Have you ever seen the ISS go overhead?
Yes. Yeah. Well, I don't know that it. Well, hold on. I've seen something that looks like the ISS go overhead. I don't claim to know what that was. I saw something, but I mean, I've filmed geese that look like they're doing the same thing. So it's.
Yeah. Have you seen the people filming the transit of the ISS, either of the moon or of the sun?
I've seen Red's rhetoric,
and
that's what I'm referencing. I've seen Red's footage, and I've got footage of geese that looks like that. So
you have footage of geese where it looks like the ISS, like with solar panels?
I mean, they're traveling at a slower speed, but it looks like those birds could be in outer space, just like that ISS footage was. You see what I'm saying? Obviously, in Red's footage, that whatever that was that he filmed was traveling at a much higher rate of speed, but it still looks the same. That the proximity between the geese and the moon look like the same proximity between Red's ISS and the moon. See what I'm saying? So it looks very similar. So I don't necessarily so that footage doesn't necessarily prove the ISS. It just proves that something moved in the sky in front of the moon. That's all it proved.
But
it proved that he definitely filmed something, but I don't think it was an ISS at 400 miles up in the sky or whatever. You know what I mean? Or
are you familiar with the one that he did where he had Astronomy Live, I think 1 kilometer away, and they sort of triangulated how high it was because it was 2 different observers? So in other words, using very simple trig, they determined the ISS to be, I don't know, I guess about 220 miles up, if I'm not mistaken. Oops.
Okay. And so all those observations are made off a straight line of sight.
Yes. Right. But the thing
so
is,
if you're going to assume that the moon is with those numbers, you'd have to assume that are they using a distance to the moon? No, you wouldn't need the distance to the moon.
No, they're not.
It wouldn't even
The moon is extremely far away for their calculations.
Right. So that wouldn't even matter. So what you're saying, they got 2 different points on the Earth, and they're just filming something in the sky and literally just triangulating the distance, and they're determining the height.
Right, but not only the height, but the speed matched. Everything matched, and the shape. So. Hey, it's 11 o'clock now, so I'd love to have another conversation with you at a later date. But do you want to have any last words? And I won't interrupt. I'll put myself on mute. So
no, that's cool. Yeah, I just encourage people to go check out that Zenith Atlas channel. I've got footage there. There's a Cell Earth evidence playlist. I think people should really look into the plumb bob experiments, and pay attention to what surveyors are saying. Look at these experiments that people are doing with lasers. Can we really determine if we're just following the curvature of water? Then are we really determining the curvature of water, or are we just fooling ourselves? So look into gravity, look into all that stuff. Definitely look into the model, see what makes more sense for you. Thanks for tuning in. Thanks for having me on, Charles. I really appreciate it, and I look forward to talking with you again.
All right. Thank you so much, Joshua. So, folks, that was Zenith Atlas. Please make sure you check out his channel. I'll put a link in the description once I edit this video. But thank you so much for joining us, and thank you to everybody in the chat. Signing off now. Have a good night. Bye-bye.